Hi, I am Greg and I am here to tell you about geometric dimensioning and tolerancing. So what is GD&T all about? Why is it important you know about GD&T if you work in the manufacturing sector? What is GD&T? GD&T is basically a system for defining and communicating engineering tolerances. It uses a symbolic language that explicitly describes nominal geometry and its allowable variation. A simple example is a hole with a diameter specified along with its tolerance. It tells the manufacturing staff and machines what degree of accuracy and precision is needed on each controlled feature of the part. An example is a shaft with a diameter and its tolerances. This helps the person on a turning center know how much of an accuracy is required. GD&T is used to define the nominal, theoretically perfect, geometry of parts and assemblies, to define the allowable variation in form and possible size of individual features, and to define the allowable variation between features. An example is the circularity in the shaft. Dimensioning specifications define the nominal, as modeled or as intended geometry. One example is a basic dimension. For example, the diameter 0.3750 is the basic dimension. Tolerancing specifications define the allowable variation for the form and possibly the size of individual features, and the allowable variation in orientation and location between features. The same example of the circularity in the shaft can be taken. There are several standards available worldwide that describe the symbols and define the rules used in GD&T. One such standard is American Society of Mechanical Engineers or SME Y14.5. This video is based on that standard, but other standards, such as those from the International Organization for Standardization or ISO, may vary slightly. The Y14.5 standard has the advantage of providing a fairly complete set of standards for GD&T in one document. The ISO standards, in comparison, typically only address a single topic at a time. There are separate standards that provide the details for each of the major symbols and topics below, example, position, flatness, profile, etc. According to the SME Y14.5 standard, the purpose of geometric dimensioning and tolerancing is to describe the engineering intent of parts and assemblies. The datum reference frame can describe how the part fits or functions. GD&T can more accurately define the dimensional requirements for a part, allowing over 50% more tolerance zone than coordinate dimensioning in some cases. Proper application of GD&T will ensure that the part defined on the drawing has the desired form, fit and function with the largest possible tolerances. GD&T can add quality and reduce cost at the same time through producibility. Fundamental rules. There are some fundamental rules that need to be applied. All dimensions must have a tolerance. Every feature on every manufactured part is subject to variation. Therefore, the limits of allowable variation must be specified. Plus and minus tolerances may be applied directly to dimensions or applied from a general tolerance block or general note. For basic dimensions, geometric tolerances are indirectly applied in a related feature control frame. The only exceptions are for dimensions marked as minimum, maximum, stock or reference. Dimensions define the nominal geometry and allowable variation. Measurement and scaling of the drawing is not allowed except in certain cases. Engineering drawings define the requirements of finished parts. Every dimension and tolerance required to define a finished part shall be shown on the drawing. If additional dimensions would be helpful, but are not required, they may be marked as reference. Dimensions should be applied to features and arranged in such a way as to represent the function of the features. Additionally, dimensions should not be subject to more than one interpretation. Descriptions of manufacturing methods should be avoided. The geometry should be described without explicitly defining the method of manufacture. If certain sizes are required during manufacturing but are not required in the final geometry, they should be marked as non-mandatory. All dimensioning and tolerancing should be arranged for maximum readability and should be applied to visible lines and true profiles. When geometry is normally controlled by gauge sizes or by code, example, stock materials, the dimensions shall be included with the gauge or code number in parentheses following or below the dimension. Angles of 90 degrees are assumed when lines are shown at right angles, but no angular dimension is explicitly shown. This also applies to other orthogonal angles of 0 degree, 180 degrees, 270 degrees, etc. Dimensions and tolerances are valid at 20 degrees C/101.3 kilopascals unless stated otherwise. Unless explicitly stated, all dimensions and tolerances are only valid when the item is in a free state. Dimensions and tolerances apply to the full length, width, and depth of a feature including form variation. Dimensions and tolerances only apply at the level of the drawing where they are specified. It is not mandatory that they apply at other drawing levels, unless the specifications are repeated on the higher level drawing. Let us talk about symbols. The types of tolerances used with symbols in feature control frames are equal bilateral, unequal bilateral and unilateral. Tolerances for symbols are equal bilateral unless otherwise specified. For example, the position of a hole has a tolerance of 0.020 inches. This means the hole can move plus or minus 0.010 inches, which is an equal bilateral tolerance. It does not mean the hole can move plus 0.015 to minus 0.005 inches, which is an unequal bilateral tolerance. Unequal bilateral and unilateral tolerances are specified by adding further information to clearly show this is what is required. Here are symbols that you will frequently see in manufacturing drawings. They are broadly classified under form, profile, orientation, location and runout. Here are symbols for various other features like free state, least material condition, maximum material condition, projected tolerance zone, regardless of feature size, tangent plane and unilateral. To conclude, let us talk about datums and datum references. A datum is a virtual ideal plane, line, point, or axis. A datum feature is a physical feature of a part identified by a datum feature symbol and corresponding datum feature triangle, an example of which is shown below. Thank you for watching the video. Please subscribe if you wish to know more about GD&T.